In 1982, the US Treasury realized that their production of coins, specifically pennies, was becoming unpractical and ironically too expensive. So they started making pennies out of lighter and more cost-effective materials. Despite their coppery color, most pennies today are actually almost 98% zinc, with just a thin outer layer of copper. This coating is what gives the coins their distinctive color, but pure copper isn't the only thing these coins can be coated in, and through a few simple reactions they can be made to look silver or even gold. For this experiment, you'll need, of course, copper pennies, sodium chloride or table salt, vinegar, zinc, distilled water, and a 1 molar zinc chloride solution. The pennies can be from any year, as the reaction should work with either pre- or post-1982 pennies. With this experiment, it's also important to be careful with the granular zinc and the zinc chloride solution. Both can cause skin and eye irritation, so it's important to, of course, wear eye protection and avoid contact with these materials. So the first step is to clean the pennies, as this will improve our results later on. We'll use a solution of sodium chloride and vinegar to clean the coins. Also make sure to thoroughly rinse the pennies afterwards, otherwise the salt and vinegar solution can cause a bluish-green compound called malachite to form on the coin's surface. Also avoid touching the coins from here on out, as this may interfere with the reaction. Next, we'll mix the zinc and zinc chloride solution, heating it to a boil. At this point, we can add the pennies and watch as they turn from copper to silver. Now we can take these silver pennies and start the next part of the experiment. All you have to do is put them over a heat source, in this case I used a hot plate, and watch as they turn from silver into gold. So why is this happening? Well, for starters, the first reaction that occurs is the one we use to clean the pennies. Over time, coins become coated in a layer of copper oxide, a compound formed through the synthesis reaction between the coin's copper layer and oxygen gas. By mixing the salt and vinegar, the vinegar's acetic acid and the sodium chloride react in a double replacement reaction, producing sodium acetate and hydrochloric acid. The copper oxide is a base, while the hydrochloric acid is, of course, an acid, so the two can react in a neutralization reaction. This produces a salt, copper 2 chloride, and water, and by breaking down the copper oxide into these two compounds, the coin is cleaned. Next is the reaction that turns the penny silver. What's really happening here is that the zinc atoms in the granular zinc and the zinc chloride solution coat the penny and make it look silver. The zinc ions in the zinc chloride are reduced to form metallic zinc, and the granular zinc is oxidized, becoming a positively charged ion. These zinc atoms then form a brass alloy on the coin's surface. This alloy contains over 45% zinc, which is what gives the penny its silver color. But to turn the penny gold, we need to add more heat. When the zinc-coated penny is heated, the zinc and copper atoms move around more, and the zinc migrates through the copper to form an alpha brass with a lower zinc content, giving the alloy its distinctive golden color.